Welcome back, everybody. Today is going to be fun because you have requested for me to help you fixture this gate. This gate looks a little tricky, has some cool arches in it, and it's a little bigger than the table. So how would you go about fixturing it? Well, I'm going to show you how I do it right here today. So I got a recommendation from the forum to see how I would fixture something like this, a gate. We have a couple little weird details like this double arch, and basically what I think we're looking for is a template for these arches to be able to conform, make sure we are making what we want. And of course, if we had two of these, maybe we are having a matched gate that spin together or something. We might want to build two and they match. So we need to set up some fixtures to build identical parts. So I've already drawn the gate according to the drawings. And remember, this is just for demonstration purposes. I would basically start in CAD and draw it out like this if there isn't already a CAD model. And then from there, I would create what we call a fixture map. Because this is a pretty big part, I'm going to start with the Fireball 102 by 54. And this is what the table looks like. And then from here, I'm going to create an assembly from this part. We're going to select it. So I'm using SolidWorks to do this. And any 2D or 3D CAD, you can perform this task. Here we go, there's my table, it's fixed in place. And now all I need to do is bring in my gate. So I'm gonna insert components, select my gate, and there we go. I'm gonna plop it down on the table. But as you can see, I'm kind of hovering above the surface here. And it's at this point in time, I need to figure out where I would like to orientate this. Do I wanna build it going sideways like this? I need to pick a direction. That makes sense. The first thing I want to do is I want to mate the surfaces. So this surface and this surface, I want to be coincident like that. Okay, so now we're sitting nice and flat on the table. Now I just kind of need to look at this for a second and just stand back and stare and just kind of pick a good spot. Anytime you're fabricating, you're going to be working around the perimeter because this is where you're going to be standing. So positioning parts close to the edge is very convenient. So if you're doing a lot of welding here in the center of the table, you're bending over a lot. So try to avoid positioning parts in the middle of the table if you can. Knowing that I've fabbed stuff like this before, we want to leave a good 8 to 10 inches around the perimeter for some blocks, fixtures, and clamps. So something like this is probably going to be where the gate is going to live when we can do fabrication. Okay. And then I can also see that I'm hanging off the table. So we're going to need to do some table extensions. So I think we should get ourselves a good line over here, and we can do that with some fence blocks. Just a nice reference edge to start from. So I'm going to insert some components again, go to browse, and I'm going to go by 1x4 fence block. So I'm just going to plop him down right here, and I'm going to do some mating. I'm going to mate the bottom of the block with the tabletop, and then from here I just get to pick a hole. These don't have to be exactly, we can move these around later, but they're gonna give me a good reference. So I just pick the hole bores, hit mate hole bore with this hole bore, and as you can see, we've locked ourselves in position. And then in SolidWorks, if you want to copy a part, you just hit Control, click, and you just drag. Okay, so I'm gonna do the same thing down here at the bottom of the table. So I'm going to select that table, select that tabletop, hit mate, and it's automatically going to connect the two. And we'll probably come in one hole, select that bore and that bore and that bore. Now I have two stops. Now what I can do is I can mate the gate to the stop and give myself a reference edge to bump up against. So we're nice and coincident. See how that positioned the gate now, nice and square. As you can see, it's rubbing up against those stops, but we need to figure out where do we want to be in this orientation. Okay, so we're hanging off the table and this part is not supported. So we need to extend that. And I'm going to extend it with some tower blocks. So I'm going to insert component again. I'm going to browse to my library and I'm going to look for a tower block. And I have 14 inches, 28s, 54s, got a lot of different variations here, but I like the 14 for this, and here he is. So I'm gonna mate him so he's kind of sticking off the side here, that surface with this surface, like that. Okay, and I'm just gonna mate the holes to the slot, just like that. Okay, hit OK. Yeah, as you can see, I'm still rotating. So I'm gonna mate this surface with this surface. And you can see it is constrained in that location. And so
Once again, I want one over here, so I'm going to drag him just like that. And then mate the tops. Okay, and then we pick a hole, something that lines up, maybe there. Oh, that bore and this bore. If we wanted to add one more in the middle, we can. Let's just do it for fun, because if you have an extra tower block, you might as well support this piece a little bit. It doesn't have to be a tower, it could be a regular riser of some kind, but we're just gonna do it anyway. Meet this side with this side, and this top with this top, and then somewhere in the middle probably would be good. Okay, so we have some table extensions. And as you can see, we're still sliding, but I'm going to try to give myself as much headroom as I can to put some fixtures up there. So the best way to do that is we're just going to grab a fence block, and I'm going to mate him with this hole right here. And then this hole concentric with this hole. This hole. There we go. So now I've bumped the gate into this block, and that sets a distance. As you can see, I'm not pulling any measurements because all the measurements have already been confined in the gate. So I don't really care. We're just placing blocks around the perimeter, and then we just need to know where to put the blocks on the shop floor. That's kind of the idea. Add another block here. This guy and this guy. Sure, this guy. And if we wanted to add one here in the middle, we can do that too. So now we just need to work on the side over here. I can tell that it's not landing on a grid or anything like that, so we're not going to be able to use a block. So what I'm going to use is a tooth block. So I'm going to go to insert components again, browse my library. Now all these CAD models you can download off of the Fireball Tool website, but they're also very simple to draw. They're just basically squares or rectangles, and sometimes drawing them in your own CAD system and simplifying them so it doesn't bog down the machine is very beneficial. So this guy, we want to give him some distance here, as low as we can. Now the tooth block works like this. It has a slot, and we need to constrain him in the slot. So I'm going to give myself some tangency, but what I forgot to do is get the table set. Put him on the table. There and there. Yep. Okay, so you can see we're pivoting around that hole, and we want to give this hole some tangency there. So this is the way the tooth block works. Whatever the first hole is that matches up concentrically with the slot, this tooth block is technically in its 0, 0 position, which means it can't technically go back anymore unless you skip to this hole, right? So this would be 0, 0. So what we're looking for when we generate a map of this is how far extended, which means is how far forward does this block need to slide to give us our measurement or intersect our part, and how far did that move off the center line of this hole? So from center of this hole to the center of this hole, what is that distance? Big question mark. And we'll get to that in a minute. But in the meantime, we want to mate this so it's up against our part. It sets the distance. Boom. Okay. Now he's constrained. I can't move him forward or backwards. He's aligned with the holes, and you can see we're not over the top. We don't know what he's extended out yet. We will get to that when we do some measuring. Okay. So once again, we want another one of these guys. You guys want these up here as high as we can. Kind of want to stay away from the corner because we're going to be doing some welding there. So probably right there would look good. Like I said, when you get onto the table and you find that there might be some interference in parts, you can slide blocks over a little bit, shift a row up or down. That's not going to hurt anything. And then we're going to mate the face of this to the face of this. Now, if you notice, this block does not have a riser on it. That's because our tooth blocks you can configure with whatever riser you want. And in this instance, it's just the chassis. And this is a very simplified version of the tooth block. It actually doesn't have the tooth drawn in the model because it just bogs the whole system down. It's not necessary. All we need to know later is how far it's extended. Here's what we're building as a template, right? So as you roll this piece of tubing in your tubing roller, we want to give ourselves a couple places to check and make sure it's going to be at the right elevation. And is the arch correct? I'm going to do 4 points, probably one here, one here, here, and over here. So I'm just going to drag this block again over here. So this is the front of the block. We can use either side, but the scale reads correctly if you're using the hole. Let's put him about here. I think that will give me enough room to put a tack weld in there. So let's make this sidewall tangent with this hole. And then to square them up, we are going to do this one and this one. Okay, so now as you can see, we're sliding once again, and we want to use the corner of this block. This is going to give us a really precise point to touch against and something we can measure off of and view. If we were to turn this block to where it's perpendicular with this arch, it's still going to only be touching on 2 points. So it's really not ideal. And through my years of doing this, we want to try to keep the blocks in the grid as much as possible and resist the urge to pivot them. So in order to touch this block, we're going to do the same thing. I'm going to touch this corner right there and then touch this surface and hit mate. And there you go. That is a fine point on this arch that defines the location. Now you're probably asking me, Jason, why didn't you center this gate on the table so that it's even left and right and all you have to do is mirror parts over? We can do that, but it's really not necessary. We can get the same results by having the part kind of skewed and not sitting even in the grid. So I'm going to mate him up, and then I'm going to move him. Let's move him over here for fun. So we were, what, 2 holes off? Let's just do the same thing with him. Now these guys, once we set him in location, we can't move him because we're working with an arch. So we kind of have to pick correctly. And I think I can get enough clearance there to get a good tack weld or something. So I think that's where I would put it. And we're going to repeat the process, that corner and this surface. Okay. So there would be 2. You could probably get away with 1 more in the middle, but I'm going to do 2 anyway. This is kind of where it's kind of nice up to the fabricator. If you're drawing fixture maps for your company guys, you probably want to give them more than what they need. It doesn't take very long to add a few more pieces. And if they don't need them, they just won't put them on the table, if that makes sense. So I put 1, I'm just kind of looking at this from the top. How about this row? This looks pretty good. This is where I would put it if it was me. Now, I've built gates before like this, and what I've had to do is when there's arches involved, there's a lot of templating and layout on the shop floor to get arches of this diameter. You're swinging a soapstone around on a big string, trying to get this arch laid out right to match the drawing. And then you're on the floor matching, cutting. Right here, what we're doing is we're basically doing the same thing. We're giving ourselves the template that we would have drawn out on the floor. So that time is about the same amount of time as I'm doing right now. And so I don't see this as being a waste of time doing this, because I'm going to have to create some sort of drawing anyway, either if it's on the floor or on the table. But I'm in a nice comfy chair in the air conditioning, and this is going to be a breeze when I get down on the shop floor. Like, this is just going to go really fast. I want to hit that one. Yeah, I think this one and this one. Yep. And I know that when I am done with this fixture map, it is going to be correct. There we go. So there's 4 points. Now when I roll my radius, if we continue this rolled part down, I could start making some cuts as I lay this over the top. Potentially, you might want to make some risers on the top of these. Put a riser like this here so that you can literally rest the rolled part and extend it off the sides. And that way you can come in underneath and make a mark and line it up and then make a nice good cut. Because rolled parts are always a little tricky. This would give me a really good template to go off of. Okay, so the top is much the same. It's just reverse, so we just flip it around. Okay, so let's do that real fast. I'm trying not to talk so much. We'll just buzz through this really quickly. Pretty much the same thing. Should we just stay in the same parallel? Sure, we'll just stay in the same parallel. So let's talk about CAD for a little bit. I like SolidWorks because there's a lot of information out there already. You can learn CAD just by watching some YouTube videos. What we're showing here isn't anything really difficult. So I took a 1-week CAD class to get started. But now I think I could probably just watch some YouTube videos and get away with not having to go to class. But it was nice to have an instructor. But this was in 2015, and there wasn't a lot of YouTube videos at the time giving good instruction. As you can see here, I'm just working my way around, not doing anything too crazy here. Same thing over and over and over again. Now remember, we gave ourselves plenty of room at the edge of the table. This is why you gotta have a little bit of foresight. See, we're all on the table, and this is what the beauty of CAD is. You're not wasting your time putting fixtures down on the shop floor and then having to come back and move them around because you didn't get the part positioned correctly the first time. I know I'm gonna hear a lot in the comments. I wouldn't do any of this stuff. This is a big waste of time. But for me, I've learned through my career that I like doing things once and do it right the first time. I've cut enough things apart and run the skinny wheel to not want to have to do that again. So a little extra preparation I found goes a long ways. But what's neat about this is that I could technically give this plan to any one of you guys who have a Fireball table, and you guys could recreate this, and we could technically be building the same thing in different states, and we'd be using the same unit of measurements because we're using the fixture table, and we could technically recreate this, and our two parts should come together and they should match, right? So there's something kind of cool about that, knowing that we're using the same measuring tool. Now, if this was somebody else's table, I don't know how I would do this. The Fireball system is just so easy to use because of our tooth block system and this fixture mapping layout and this whole process. I kind of feel like the other table companies just kind of give you a bucket of Legos and kind of expect you just to go for it, but I'm not quite like that. I want to see you guys have a process, complete the task. There we go. So that took me a little longer than what I was anticipating because I'm talking too much. But that's how I'd set this gate up. Okay, looks something like that. What I want to do is bring in what we call the layout, which is the grid to lay out all the holes. So I'm going to insert component. We need a hole ID is what we're looking for. Hole indicators. Here we go. And so in SolidWorks, it's always kind of tricky to lay the holes out. If you put hole layout in the table, it really bogs the machine down. So what we've kind of come up with here as a team is we just kind of created our own little part, which is these holes. Looks like this. If you get real close on them, they're just extruded text. Or let me go the bottom of this with this and mate it. Okay, so now all our holes are all laid out all the way out to 50. Yeah, looks good. And now we know every hole. Now we just need to know the measurements. And the way I'm going to do this is I'm going to start creating my map. So I'm going to save this. Now I'm going to make a drawing from assembly. Got to preload a little map in here. Okay, so if you've never seen this before, SolidWorks gives you a drawing sheet. And you have all your isometric views, your current view, top, bottom, side, right, left. But all we want is the top. And then as you can see, it's very small. So I'm just going to click on it. And I'm just going to use custom scale. Let's do 9. All right, so the first thing I know is with the fence blocks, we already know where to place these because you're in R, whatever, 1, grid row 1 or 2. So we don't need to label anything here. We can see the tower blocks are in the very last row. We don't need to do any labeling here or here. What we do need to label is how far extended, like we talked about, are the tooth blocks. These 8, 9, 10 tooth blocks, where are those located? So what I want to do is in here we can find the center of the holes by toggling this little icon right here. And this gives us the center of every single hole. So this gives us the center of this end of the slot, which is technically the hole. And this is what we're looking for. This distance right here to here. How far off did this tooth block extend off of that hole? So I know from experience that SolidWorks kind of has a pain in the butt selecting those marks. So I'm just going to come through here. That one looks like it's pretty much right on the money. And just kind of give myself these targets to pull measurements from. That one's right on the money, isn't it? This one's barely moved. So you see how this one is, this hole is underneath this one? See how that's technically forward? So we need to pull the arch of this, which is this right there, to this one back here. This is our hole, our next hole, technically. You gotta kind of watch out for that. This one's almost right on the money. Sheesh, that is so close. So let's pull this arch. So we're barely pulled out. But what I'm going to do is I'm going to grab that hole number because we're so close right there. I'm going to grab the next one back, and it won't hurt anything. Okay, but that is awfully close, practically right on top of each other. I bet you if we measured that, we'd be in thousandths of an inch. Okay, so this bottom one, almost close enough just to call it 0. I'm going to pull there to there. Okay. And I think I got them all. So as you look here, this one is in the same grid row as this one. So these two are identical. So if I just give ourselves the call out for this block, I don't need to do this one because it's pretty much self-explanatory. But because I'm on camera, I'm going to do it anyway. But if this was for me, I would not label this. Okay, so I got my marks there. So I'm going to come up here and hide my center marks because it just gets confusing. Okay, and then SolidWorks, as you go up here to Smart Dimension, see all my little points have pulled up. And I'm just going to click on the point, and as you can see, I'm in 5/8 of an inch. So in SolidWorks, I want to make sure that my units are correctly. If we wanted to change this to metric, we can. 16ths fractions is what we're rounding to, is the nearest fraction, which means the worst case scenario we're going to be off is 30,000ths of an inch. That's the absolute worst case. And I think that it's well within tolerance for this. So we know it's 5/8, so I'm gonna just pull this down into a position where I can see it. If I kind of put it up here, it kind of gets lost. Sometimes that's okay, but I like to kind of drag it out so I can find it. And once again, I wouldn't label both of these, but we're gonna do it anyway. And then we're just gonna click the spots, and then I can drag it out here so I can see it. 2 inches. I'm just going to pull them off to the side. This one's 3/4. Come up with him. 11/16. 2 inches. Technically, these blocks could probably be in the slot and be okay. I would just put a pin right there and then bottom it out, since that's what this distance is from there to the edge. And 15/16. Last one, 2 inches. So there's my map. It's all laid out. I could give this to a guy on the shop floor and he could recreate this for me. So now that I have the fixture map done, all my dimensions are there. Let's go down on the shop floor and let me show you what it looks like.
We're out of CAD now, got my fixture map, and I'm going to show you how I set it up. All right, to get started, we're going to need 3 tower blocks. 10 tooth blocks and washers, 10 tacking bolts, and 10 anti-rotation pins, and 4 fence blocks. All right, let's start with the tower blocks. We're just gonna follow the map. These things are pretty cool. They have slotted holes going one direction and the other, but we're not gonna be using the slots. We're gonna be bottomed out into the ends of the slot so it doesn't move. It goes like this. Okay, these just basically need to be finger tight. So the bolts we're using, they're called tacking bolts. And as you turn this knob, these balls at the end of this shaft expand out. That way you don't need a nut and a bolt. So this is just a one-sided operation for this fastener. That's what holds everything onto the table. These tower blocks are pretty heavy duty and they're designed to hold a lot of weight. And what's cool about them is they're 1-inch resolution. So as you're using them off the table or on top, you gain a little bit more adjustment. But the cool thing is we've already planned all this out so that it's easy to do here on the shop floor. Okay, so the next thing is we're gonna set our fence blocks up. It's a 1x4 block. Those are all the holes, and it has fixed pins in the bottom. You can take the pins out, we can bolt them into place, or just use the pin like a Lego. And they just drop right in the holes right here, just like that. So if you look at the table, we have a grid in it, 1 through 50 along the front and A through Z along the edge. And they've been etched in the table so they can't ever wear out. That's the whole ID number. The next step was we're looking at tooth blocks. This is the tooth block I was talking about in CAD. You can see the teeth on the bottom and the teeth in the washer. The washer goes down first, and this first hole, like we have in CAD, says it should be placed in 34, hole A, which is this one right here. Okay, so I put the washer down where it needs to go, corresponding with the map. Now the top goes back on. This is the actual block. And then I put the pin in the hole. Now you see as it locks it in position. Now I have to just figure out how far extended is it. Remember we talked about this hole lining up at the bottom. How far forward is the block? And that's the measurement that we gave ourselves in CAD, which in this instance is 5/8 of an inch. Okay, and then we put the anti-rotational pin in the back. This keeps the block from pivoting and keeps it locked down. And just with a simple hand tighten, this block is not going to go anywhere. And now we have a nice good stop to reference from. This is exactly why the fixture map is awesome. I'm off one hole on this tower. So what I'm just going to do is remove one of these bolts. That's the cool thing about the map, is that it checks yourself. So I'll just off one hole, no big deal. We didn't weld anything to the table. We didn't mismark. We didn't label. There's nothing to scratch off. That was it. That was the fix. So it's okay to mess up. It's easy to fix. All right, so now we take that same principle with the tooth block and we're gonna go all the way around the whole perimeter and we're gonna do this really quick. So this one's 34. We know we're in the right grid because these two are matching, right? We're on the far side of the gate. I'm in grid 34. I can use the grid lines, follow the hole up. And then this next block is in row R. So I just look over to the side of the table, QRS, which is right here. And we know that we're matched at 5/8 of an inch. So I just move the block over and I lock it down, repeat the process over and over and over again. B30, B30 at 2 inches. X 22 at 3/4. X 13 at 11/16. So all the way up until now, I've been using an 1/8 inch washer. Looks like this is labeled, which puts this block on every 1/8 of an inch centers. The plans call out for 11/16, which requires this washer, which positions this block on every 1/16 of an inch. Early models of this, we had a block that you can flip, flop, and get those measurements, but we found that if you get it positioned wrong or backwards, everything is off. So we've decided to separate them so there's no confusion. So we're on 16ths and we just go to 11, 8, 9, 10, 11. So it's very fast to get set up. O. There you go, all done. Just like that, nice cool template to lay our stuff into. That was much faster than laying something out by hand and scribing stuff on the table and trying to swing a circle. We didn't weld or tack weld stuff to the table that we needed to remove later. If you don't like the design or like the arch layout, we can come back and change this again. And we're just gonna use this piece of scrap aluminum just to kind of show you, if this was the real tubing we were rolling, we'd have rolled it and we would be using these blocks as the template, see? But you guys get the picture. Now I have some stops. Now, if you wanted more stops than that, you can go back into CAD and add some more stops. But this gives you a really good distance and something hard to push up against with a clamp. Hopefully you guys liked to see how easy it was to set up on the Fireball fixture table. I've really perfected this design and really how easy it is to get from something in your brain and into CAD and here into real life without ever pulling a tape measure. Can you believe that? So thank you for submitting your gate drawing. Hopefully this answered your questions. I'd love to do more of this stuff. So if you'd like to post your drawings at the Fireball Tool forum, I'd happily take a look at them. But until then, thank you guys for watching and I'll see you on the next one.